Hello. I'm just going to create this video here to show you how to calculate the percentage uncertainty and the absolute uncertainty for our volume. And this all stems from the simulation lab that we did today, trying to calculate volume and how does temperature affect that volume. So up here I have a data table, and this is just one I just made up not too long ago, and it should be similar to what you have. Now I gave you the depth, and the height was relatively constant at 5.3, depth at 1. And for the first one, I just kind of calculated, or sorry, I didn't calculate it, I measured it out to be 2.3 nanometers. So to find the volume, I did it through the Google Slides, but volume was pretty easy to calculate. It was our height times our depth multiplied by our length. So that was pretty good, and calculated out to be 12.19, 12.2. But we want to find out how good is that value? What is the error or uncertainty that's inherent within it? So to calculate the uncertainty, because it's a multiplication, I have to convert everything to percentage uncertainties. And for the percentage uncertainty for my volume, it's going to be equal to the percent uncertainty of my height plus the percent uncertainty for the depth plus the percent uncertainty for my length. So it's all of those guys added together. So to calculate my percentage uncertainty for height, the height was measured kind of using this digital thing on the simulation. So we used the smallest value, and its smallest value was 0.1, so that's the absolute uncertainty nanometers for my height. So that's the absolute uncertainty. And just divide that by the measurement, multiplied by 100, and that gives us 1, or a little under, 1.9%. So anytime we have a smaller percentage uncertainty, if it's below 2, we only have one decimal place. Above 2, we keep it to the whole number value. So for the percent uncertainty for the depth, I said the depth was 1, but we'll use the same absolute uncertainty, which is 0.1 divided by 1 nanometer times 100, and that gives us a percent uncertainty of 10%, and that just goes to the smallness of the measurement. So to calculate the next one, we're going to have the percent uncertainty for the length. Now that one was calculated up here, my 2.3. 2.3 here was calculated by using a ruler, measured using a ruler, but the ruler's smallest measurement was 0.2 nanometers. So I just divide that by 2 because it's analog, and that just equals 0.1 nanometers. And this is my absolute uncertainty for that measurement. So for my percentage uncertainty for my length, well, I'm just going to use that same 0.1 nanometers, even though it was measured a different way. Still the same one, divided by 2.3, which is the length I got, multiplied by 100, and that gives me roughly 4%. So I got all three percentages right now, and to calculate the volume, I just have to add them all together. So my percent uncertainty for the volume, big V, is going to be 1.9% plus 10% plus 4%, and that equals 15.9%, but I'm just going to kind of round it to 16% because it's above 2. So that gives me 16% as my percentage uncertainty for volume. But I'm not done there. That's just a percentage. It kind of means something, but I want to have it into the absolute uncertainty for that volume measurement. So I'm going to have to convert it from 16% to whatever it is as my absolute uncertainty for volume. So what I'm going to do to get my absolute uncertainty for volume, I'm going to have to multiply 16 over 100, because that's 16%, by what I got for my volume, which was 12.2, because it's 12.19. I'm going to actually just keep it as 12.2, and this is nanometers cubed. And so my absolute uncertainty will be plus or minus 12.2 times 0.016. Just going to use my calculator, 12.2, 0.16, and I get 1.95. So I'm going to get 2.0 nanometers cubed. So that's now my absolute uncertainty. And if I was writing this out, I'd say that my volume is equal to 12.2 plus or minus 2.0 nanometers cubed.